All right, so let's get started. Today, we are going to talk about, this is section 2.4. I think I wrote section 2.4 last Friday, even though it was section 2.3, so I apologize for that. So, we're going to have variables, x, y, a, b, something, on both sides. And what I'm going to say about variables on both sides is that everything is the same as before. All the rules are the same. Yes? Yes. The only thing that is different is that we have variables on both sides of the equal sign. And it doesn't make the equations any more complicated. It doesn't make them any different. It just means that we have to take an extra step to deal with those variables. And our steps are still, just to remind us, and I'm going to say usually, because it's not a hard and fast rule. Usually, we do it this way. Usually, the first step is to clear fractions. And that's like we did on a couple examples up here on the board, where we found a common denominator and multiplied everything by that number to get rid of whatever the fraction was in the denominator. I'm just checking to make sure we end up good on time. Clear fractions. The second is distribute. And that means if we have 3 times x plus 5, we're multiplying into the parentheses there, and that's 3x plus 15. Our third step, usually, combine like terms. And when we're combining like terms, we need to remember that we're talking about the like terms on the same side of the equal sign. So we're not crossing the equal sign to combine like terms here. And here's where our extra little bit comes in. We need to undo addition and subtraction twice. Once for numbers, and one for, I'm going to say instead of 4, one to get variables together on one side. So this is how we deal with the variables on two sides of the equation, is we undo addition subtraction by getting all the x's together on one side, all the y's together on one side, whatever variable we're dealing with. And then our last step is undo multiplication and division. So we still have the same 5 steps, and we've listed these 5 steps for a couple of times now. But to deal with the variables, we just need to undo a plus addition or subtraction to get all the variables together on one side of the equal. All right, so we're good with our steps. So I just want to go through a few examples. All right, so let's say we have 5x plus 13 equals 2x plus 22. So, still an equation. We're still trying to get x by itself. I'm going to say solve for x up here. I'm just going to say solve. Solve means get the variable by itself. So, what I usually think of, and Ms. Lindgren, tell me if you work different. I like to think of getting the variables together first. Yeah?
Yeah.
Go ahead.
Would we start by subtracting like maybe 2x?
Yes, that's exactly what I would do. I would say, let's get all the x's over here on the left side, so let's subtract the 2x. And I'm drawing my lines like before. We could do it the other way. It would work. Now 2x minus 2x just gives me 0, so those go away. This 22 comes down. 5x minus 2x is 3x plus 13 equals 22. What would happen, in just a second, what would happen if we decided to do the other way and subtract 5x from both sides? You get negative 3. And the reason I thought let's subtract the 2x is to avoid getting a negative. That's usually how, it'll work the other way, but I like to not have to deal with negatives if I don't have to. If you like to deal with negatives, it doesn't matter. You can do it either way. Our next step here. Yes?
Subtract 13.
Subtract 13. Hopefully this is familiar now. 13 minus 13 is 0. Those go away. The 3x comes down. 22 minus 13, 9. Now, there's only one thing to do. Divide by 3. Those go away, and I get x equals 9 divided by 3 is 3. And we could check our work if we wanted by plugging 3 back into the equation for x on both sides. And we should see that whatever we get, let's look at it, 5 times 3 plus 13 equals 5 times 3 is 15 plus 13. Let me move this. That's 15 plus 13, which is 28. 2 times 3 plus 22 is 6 plus 22, which is 28. And those two things are equal, and that tells us we did this problem correctly. So, really we're not adding that much to what we did before. We just need to deal with getting all the variables together on one side of the equal. Any questions? Okay, let's look at another one. 2 times 3x plus 1 equals 4 times x minus 5. All right, so looking at this one, let's think about it for a second before we start doing things. What would we want to do first here? Hang on just a second. Let's see. Do you have an idea? Raise your hand. Yeah, what should we do? Let's distribute first. We have these parentheses, so let's distribute first. And I'm going to distribute in both sets of parentheses. That'll work. So here I get 2 times 3 is 6x. 2 times 1 is 2. Here 4 times x is 4x. And 4 times negative 5 is negative 20. And now it looks just like what we did before, right? It looks just like this one, just with different numbers. Yes? What do we want to do first? Yeah? Minus 4, what you were going to ask? No, once we distribute, the parentheses go away. That's a good question. So you said subtract 4x? I like to get the variables together first, after we distribute. So I'm going to subtract 4x, and if we do 4x, we don't get a negative. It's okay if you do it the other way. It'll still work out. Well, 4x minus 4x is 0, so I end up with a negative 20 coming down. 6x minus 4x is 2x plus 2 equals negative 20. Ah, this is easy now, right? Next step. Subtract 2. These go away. 2x comes down. Negative 20 minus 2. Negative 22. Good. Last step. Divide by 2. Very nice. Those go away, and I get x equals negative 11. All right, I want to give you all one to try. Is that a stretch or a hand raised? Stretch or a hand raised? Stretching. Okay. All right, I want you all to try this one. T plus 8 equals minus t plus 6 plus 2t. So give that one a try. There's a couple of ways that you could go about this one. And you can talk with a neighbor if you want. Sure, that's a good question. Andrea said, can I switch out the t's for x's? Can I write x instead of t? That's fine. If you don't like t, write it as x. T, x, any variable just means something that we don't know what it is. It doesn't matter how we write it. Just make sure you replace all of them.
Oh, that means negative.
That means subtract. Negative x means subtract. That would undo that. Yes.
Multiple versions of t. I mean, you can still add them. It doesn't mean it's actually a fraction.
So someone said there are 3 t's. What can we do with the t's on this side? Can we combine like terms here?
Yes.
Yes, we can combine like terms.
Where do you want this?
Oh, just anyway. Yeah, it's the teachers. We hear a lot that students don't think we hear.
I was mumbling the three F's for myself.
Yeah. We're pretty good at that.
I put 2 reminders we need to say when we have those tomorrow.
Okay.
Just put a sticky on top so no one forget.
Okay. Very good. Very good. Will you? So he made a comment to his partner. When you don't have a number in front of the t, what does that mean?
It's 1 T.
1 t. This just means negative 1 t. When there's no number, it means 1. Very nice. All right, did we get this? Did everybody get Oh, what happens?
There's no T.
Yeah, what happens with all the T's? They vanish. Oh boy. Well, let's work this out. This gives us an interesting thing that can happen. All right, so we said we could combine like terms. So I'm going to write t plus 8 equals negative t plus 2t is t, and we get a plus 6. Now let's get the variables together. Subtract t from both sides. Yes, question?
How do you get T plus 6?
Well, negative t plus 2t is 1t. That's 2t minus t, and then the 6 just stays there. These go away, and I get 8 equals 6. What? Does 8 ever equal 6? No. We call this one, this can happen, we call this no solution. When we get variables on both sides of the equation, we can get something that doesn't have a solution. So when you get something that's impossible, like 8 equals 6, 0 equals 5, negative 1 equals 7, that is no solution. Did everybody get that all the t's went away?
Yeah.
No? If you didn't get that all the t's went away, do you see where hopefully you see where you went wrong?
This is a really big deal, you guys. This 8 not equaling 6 being no solution. This follows you. This is a big deal.
It comes
and
up.
It's okay. It happens.
It comes up quite a bit in math where we like it when there's a solution, but sometimes there's no solution. Let's look at another one. We'll do this one together. 2a plus 3 equals 1/2. 6 plus 4a. 2a plus 3. These are a's. Actually, I'll rewrite it. I'm going to write x since we like x's better. All right, so what do I want my first step to be here?
Distribute.
Let's distribute. So I get 2x plus 3 equals 1/2 times 6 is
3.
half of 6, 3, and half of 4
2.
is 2. And now what do I want to do?
Subtract 2.
Let's get the x's together. Let's subtract 2x from both sides.
There's no solution.
Well, wait. Let's be careful. You're close, but we have to be a little more careful here. Those go away. Those go away. I get 3 equals 3. When does 3 equal 3? Always. 3 always equals 3.
So there is a solution.
When we get this, we call it an infinite number of solutions. Now, it doesn't mean that infinity is the solution. It just means that there are an infinite number of solutions. And in the future, when we talk about graphs and that kind of thing, when we set these two equal to each other, we're figuring out where two lines cross. And it turns out that these two lines are the same line, so they cross everywhere that they go. But we'll get in more of that in the future. Yes?
So I have a question. This is our second unit, like, what's it called? Solutions, I think?
Solving equations.
Solving equations. When will our first, when's our test be?
I think we're looking at next week on block day. Well, whatever our block day is. So next week on block day is where we're thinking right now our first test will be. Tomorrow, for our in-class activity, we're going to do something that will count in the formative category. So we'll do some solving equations thing that will count in the formative category. Yes, Ms. Linger?
I know this is pretty random, but I was just thinking, have we mentioned the advanced algebra again, just as a reminder?
That's correct. You do have, if you are interested in pursuing advanced Algebra 1 credit, that is a possibility in this class. There's information in the Schoology folder, in the Intro for Algebra folder. There's big picture information. And then for each chapter, there's some additional materials if you're interested in pursuing advanced Algebra 1 credit that you should be working on. Okay?
I don't suppose random, but I just thought of it.
Right. All right. I think I'm going to stop here because we get out at 10:15, so we can so I can assign the homework. So let me reemphasize: when you get an impossible thing, 8 equals 6, for example, that means no solution. When you get something that's always true, 0 equals 0, 1 equals 1, that's an infinite number of solutions. Okay, so our homework is on page, let me get there, on Schoology, page 105, 12 through 32 even. (12 through 32 even), and 42, 43, 44, 47.
And just after checking your homework from today, don't forget those little numbers that come at the end. Yeah, you might get the 12 through 50, 32.
32.
32 even. But don't forget there's a few more problems. Because a couple of you didn't do the extras on the 50s, and you missed a point or two. And then remember, Mr. Beaver always writes his homework up here. You can find it on Schoology, and it's always over here on the board.
Thank you, Ms. Ingram. Yes, I write, and Friday's not up there yet because I need to update that today. But our homework for the week will be up on the board over there on the site.
Every even or every other?
Every even. So 12, 14, 16. So that'll be, what is that, 10 problems? 12 through 32 is 20, half of that is 10.